Hi, my name is XuxinWang and I'm a senior electrical engineering student. For my final project, the topic is Delta robot implementation in Daimola. So for some basic background introduction, Delta robot is a parallel manipulator that is broadly applied in industry for a series of benefits it provides compared to the other manipulators such as high accuracy, low moving inertia, high speed, and high stiffness. So based on all that cons, then the Delta robot is suitable for picking, packing, and pelletizing packaging processes. So parallel kinematics design makes a robot neat, fast, and silent. So this is like structure of the Delta robot. It has five important parts: the base platform, the motor and reducer, actuating arm, passive arm, and traveling platform. So here is the model I built in the Daimola. This is just the basic structure design for base plate and legs. I did a simplification for each part. So as you can see, the right hand side is the overview of the whole body of the model, and the top left is the leg model, and in the middle is the uh, base model, and like the downstairs is the plate model, and this is the motor of the Delta robot model, the model of one axis of robot with a simple load. So from here, there's a path planning, which generates reference angles for farthest kinematic movement, and axis consists of and like connect to the control bus, and this also connect to the axis. Like the axis consists of a gearbox with modeled gear elasticity and bearing friction, and a model of the electrical motor and a continuous time cascade controller. And like I restore all of this parameter in record that people can easily change the parameter instead of like adjust the parameter in each component. So here is the control design and the animation of the Delta robot model. So the controller is like the cascade controller for one axis. So this controller has an inner PI controller to control the model speed and an outer P controller to control the model position of one axis. The reference signals are with respect to the gear output, and the gear ratio is used in the controller to determine the motor reference signals. Or signals are communicated via the axis controller bus. So here is the animation that shows the structure of the Delta robot design. As you can see, it's not like identical as the Delta robot in real life, because the structure of Delta robot is too complicated and need a large amount of calculation to calculate the angle and the positions. So this is just a simple version of contains the basic structure of the Delta robot. And here is the simulation results of the motor. As you can see, it's not perfect, and it has error and noises when implementing the command. As you can see, like here, the blue line indicates the angle reference, the red line indicates the actual angle. Since there's no pre-calculated controller, the motor will not move as we expected. So the model could be used to like testing the uh, controller design or something for the users. And for future work and conclusion, like this model is really not mature. They have a lot of disadvantages, so it still needs the calculation and design for actuator, controller, and setting the parameters. This requires a lot of robotic related knowledge. So, and this also requires the analysis of the kinematic inverse solution of the robot. And you need more research on the factors of control accuracy and the methods to improve the control accuracy. So, so this model still has a lot of things needs to improve, and overall the model is like um only implement the basic structure of the Delta robot. And thank you. This is all for my final project.